I said, oh, so wait, let me write that down up here, what that actually means. It means they are averaging what, $7.50 for each policy that they sell. Policy they sell. They sell. So it sounds like they're making a ton of money, but they really aren't. They're just making $7.50. Okay, so now let's go down to standard deviation. Standard deviation is a nightmare. It's a nightmare formula. Here it is. It looks a lot like the last standard deviation, except for we had some dividing. But remember, probability has dividing in it. It is a decimal or a fraction, so it's got the dividing built in right there. Okay, this is another formula. It's just a little bit easier to compute. We're not going to compute any of that stuff though. If you want to, you can. I actually have the numbers. Here's our data. Okay, so it says the number of TVs in a household. So if you pick the number of TVs, if you pick a random household, you know, what's the probability of them having 3 TVs in there? Well, not very much. It's 0.12. What's the probability of them having 2 TVs? That's a big one. There it is. What's the probability of them having 4 TVs? Also not very big. Okay, so you can fill all this out and do it by hand, but you can also do it with the calculator. So I'm going to just fill this in real fast, and I'm going to put you guys on pause and fill this in, but then I'm going to do it with the calculator. Okay, hold on. Okay, I have filled the chart in, and so if you use the formula, this is what it's going to look like. So I have this piece already. It's right there. And the sum of all those little pieces is 4.24. It's not letting me do a point really well. Sorry about that. Minusing the average squared. Well, guess what? We know the average. Remember the average from the last, because we've already done this. So so you can go back and look, but we found that average is 1.9. And so 1.9 squared is those 2 pieces. And so you're going to get 4, I'm going to try to do this better, look how good that was. Oops. 0.24 minus 3.61. Can y'all hear my cat? She's being a pain. And if you do all that, do the subtraction and then do the square root, that's going to be what? 0.7937. Okay? But that takes a long time when you can do this in your calculator. So I'm going to give you a little refresher. In your calculator, however you get to your data, you're going to put your data, which is X, in your L1. You're going to put this is like frequency, but it's in decimal form. So you're going to put basically your frequency, which is your probability stuff, in L2. And so we've already done stuff like this when we had frequencies. And so you're going to hit your 1var stats. It's going to ask you where the data is. So your data is in L1. Let's scoot down a little bit. Your frequency, because basically the probability is your frequency, that's going to be in L2. And then you are going to calculate however that works on your calculator. You're going to get 0.7937, which is exactly what you get there. Also notice I have to point something out. If you notice, Remember, this is your population standard deviation. You also have a sample standard deviation, but when we do these weighted things, your sample standard deviation is going to be an error, or it's going to be a blank. And here's the reason. Because, let's go back and look at our frequency. Our frequency is not the raw numbers, so it's not like 1 happened, 14 times, 2 happened 27 times. It's saying 1 happens 32% of the time. So what our frequency really is 1, because all of these are going to add up to the total frequency, which in this case is 1 because we are in probability terms. So if you think about how you do the standard deviation of your sample, you do all this big calculation on the top, big sum of everything, but you but you divide by n minus 1. Well, if our frequency is 1, 1 minus 1 is going to give you an error. You can't divide by 0. So that's why it's showing you error on that, because you're dividing by 0. But when we do a probability distribution, we're doing the whole, this is not a sample, this is the whole thing. So we are always going to look at the population, and you can't even look at that anyways because there's nothing there. It's either going to be an error or it's going to be a blank space. So that's the reason. Okay, we're done with that. All right. Talk to you later. Bye.